What was the first thing you did this morning? You probably drank some water, you brushed your teeth, and if you're a wise Aberdonian, you probably also look through the window to see if it rains. Water is everywhere around us, and we're in constant contact with it. It's a precious resource, but it's also a destructive force. Understanding how water moves through the environment and where to find it is a crucial knowledge which we need in a time where everything is changing. We have climate change, economic uncertainty, and we need to be resilient. Knowledge about water and how it's stored in the environment can help us be more resilient in such context. Usually, how we will inform managers to decide on water will be by observations in the point or at the national scale. But where we have our water problems and we aim to solve them is at the intermediate or basin scale. A basin is a piece of land that captures, stores, and releases water. This is the scale at which scientists, engineers, and policymakers meet to take decisions. In my PhD, I look at the water cycle in a small basin near Aberdeen. It's mainly farmland, but now there is a town and motorway being built. I study how land management changes the way water moves through the landscape. For that, I apply two techniques to answer the questions: where and for how long is water stored, and how much we have. So first, I take water samples from the river and analyze them in the lab. And I'll analyze them for water isotopes, which can tell me where this water came from and how long did it spend in our basin. I have observed that in a farmland, water travels twice as fast as compared to natural land. This is very important information to have when we talk about flood management. On the other hand side, I look at how much water there is in the soil. I use a novel sensor that measures cosmic rays. These are particles that come from space, and their signal changes when they enter in contact with water. Instead of in one point, I'm able to estimate soil wetness at an area equivalent to 6 football pitches. This information is crucial both to farmers and resource managers, and I'm hoping to use that information to help them. But it's usually much more complicated than that, because water cycles are not natural anymore. They're complex and often surprising. In such context, we need to think about water not only as a resource, but the driver of change and also the source of our resilience. Thank you.